Good afternoon. So, math student, for those of you taking higher level math classes, especially for the one taking Algebra 2, even geometry, Algebra 2 or beyond, or pre-calc, trig, calculus. So here's one of the cool things you guys can use online. Um, you can download this one as an app on your phone, or you can just use that on your computer or your laptop right now if you don't have a graphing calculator. So this one is called GeoGebra. So GeoGebra, the cool feature about this, you can use that for the geometry, like sketching the graph, making lines, circle, those type of things. But one of the main thing that I'd like to use here, it's the graphing calculator. So they do have two different type of calculator. One is the 2D one. So the one that we always use for Algebra 2, Algebra 1, Algebra 2, Pre-Calc, and Calculus. And the other one that we can use is the 3D calculator. So you don't want to deal with this one, the 3D one. The 3D one is used for the multivariable calculus. Or for those you're taking like advanced geometry, like the 3D, you want to make like three-dimensional figure, shapes, stuff like that. So let me show the way that I use for the 2D graphing calculator. And then later I'm going to show you, how I put in things for the 3D one. Okay, so as you guys can see that the x-axis, the y-axis, and you might be wondering the template is quite similar to Decimal, but this one has a lot more cool feature compared to the to Decimal. Okay, so let me show you one of the things. So like transformation, you guys always having hard time with transformation. So let's say that we do have a equals 5, and then we do have of functions. So let's say start it off with quadratic. So the structure is always considered y equals a times the quantity of x minus h square. And then you bring down the cursor just by the click the right cursor, and then plus h plus k, excuse me. So as you guys can see that this one, it's the parabola. Oh, one thing I want to set up here. So this one, okay, so a is 5, so that means you can always adjust the bar. As you guys can see that I'm making the parabola wider as I move the bar to the left. And then also if that passed to the negative sign, that means the parabola is going to be upside down. If the value of a is being negative, the parabola is always going downward. And now another thing you can see that, okay, let's just say that a equals 1. You don't want to put in 0 for this. If that's 0, that means it's just y equals k. So that just y equals 1 right here. Okay, so just put in some other non-zero constant. So just play around with this one. So it's kind of cool thing that you can find out the graph where the data is shifted to the left, to the right. Okay, and also the graph moving up and down, things like that. Okay, so this one is for the parabola. You can do the same thing for anything, for rational, radical, linear, what else? Trig, exponential. So let's do the one with the exponential functions. So again, I just keep that the value of a, but let me delete this one here. Okay, so this one, let's say we do have y equals a times, again, you need to recognize the structure of those transformation function. So b to the power of x minus h. Okay, and then bring this one back down. Okay, so let me fix that. I need to add k here with the vertical translation. Okay, so a times b to the power of x minus h plus k. So now, obviously, for the base, you don't want to use 1 for this. Okay, so for b equals 1, so that just gives you the line. Okay, as you guys can see that right here, the base. If I change that to something else, so let's say the base is 2. Okay, so we're using that as the parent graph. So k, let's say k, it's 0. And then h is also 0. So we're just like going back to the parent graph. And then a is just some other constant, like a random constant. So let's put in 2. So again, a, so that's just the scale factor. It shows that whether that is stretching or shrinking. So if a is greater than 1, so that means it's always considered a vertical stretch. But a, it's greater than 0, but it's less than 1, then that would be considered a horizontal stretch. If a is less than 0, so that means it's going to be upside down. It's a reflection. It's a reflected over the x-axis. Okay, back to the... Okay, so the unit 1 here. So that means there's no stretching, no shrinking. And then h is just a horizontal shift to the left, to the right. And then k, which is the vertical shift up or down. Okay, so play around with that. So all you need to do is just enter that a equals 5 or a any kind of random constant. And then for the rest of the element, you don't need to enter the number, but just enter the structure after that, and you'll see that it's a transformation graph. And again, you can do the same thing for all those type of functions. So let's do the one for a trig function. Okay, again, I'm going to delete this one here. We don't need the base. Okay, so let's do the one with a trig function. So y equals a times cosine of x minus h. Well, I put in like a cosine, that looks like an inverse. So what you need to do, okay, let me go back. So you probably want to put in a times. So the times, that means it's a shift a, okay, times cosine of x minus h. You probably want to put in bx. So cosine of b times, because that b is another scale factor, times the quantity of x minus h and plus k. Okay, let's see what happens. So this one, yeah, that would be a typo because calculator doesn't recognize the other scale factor, b. So probably I have to set up another number here. So let's just say that it's just without b, okay? So again, so it's a cosine curve. Okay, so probably I need to edit right here another row. Let's say b equals 5 or 6. Again, it doesn't matter what kind of constant that you put in for this. So let me fix this one. So over here, if I put in b, or maybe like another parentheses, b. Yeah, again, the calculator doesn't recognize this. Okay, let me just re-enter the function. So y equals a times cosine of b times x minus h. Okay, and then all this plus k. There you go. It works. So one thing I just want to show you that b, so that's just a scale factor. It's an element which can affect the period. And a, it's always the amplitude for cosine and sine. And then h, it's just the horizontal phase shift. And then k, it's the vertical translation. So let me just move this one. A, as you guys can see that, see the stretching here? So a is greater than 1, it's always the vertical stretch. A, it's less than 1, but it's greater than 0, it's a horizontal stretch. And then h, so the phase shift, moving to the left, moving to the right. And then k, moving the curve up and down. And then for b, it's just that the scale factor. So changing that the amplitude or the wavelength. Okay, so play around with this. So it's a cool feature you can use. So as what I mentioned before, so I just want to show you one of the things that I can use for 3D. So let's say that you want to sketch the graph of a paraboloid. Okay, so you guys might be wondering what the heck that is, paraboloid. Paraboloid is just like a 3D graph of a parabola. So again, so over here, well, you can see that it's a three-dimensional space. So this one is just the plane intersecting the x-axis, the y-axis, and this one is called the z-axis. So what we got, so for the parabola, you can just enter into the calculator. So let's say we do have, well, if that's just a parabola, it's always y equals, okay, I'll just make up one random example. So 4 times x minus 3 quantity to the power of 2. See that? So in the 3D space, you'll see the parabola is like this. So it's kind of like a surface. Okay? And then plus 5. Okay? Like that. So it shows that the transformations, the shifting, the vertical translations, the vertical stretch. But now, what about if I want to put in as a parabola, it's a 3D. So the way you want to do it, so let's say that we do have z, which is the third dimensional variable. So that equals the quantity of x minus 3 to the power of 2 and then, well, we need to put in y as well, plus, so y minus 3 quantity squared. Okay, so as you guys can see that here, so x, which is the horizontal shift on the x-axis, and then for y, minus 3, so that's the vertical translation, so it's up 3 unit. And z, there's no changing for z. Z is just a variable. So z is the variable, so that means, so we're just solving the equation in terms of z, in terms of x and y. So we isolate that, the variable z. Okay, so can play around with this. And also you can always move the parabola. And also you can make it rotate if you want to. Okay, so you can see that, the overview. Just like a circle, you just look at that from the sky. Okay, so on the side, and you can make it rotate. So that's pretty cool. Okay, so another one I would like to do here. So let's say a sphere. So sphere, you guys use that quite a lot in geometry. So sphere, you want to enter the function. So this one would be considered quantity of, I'll just put in just the normal one, x squared without any phase shift plus y squared. And then back to the cursor, plus z squared. And let's give the constant. So in the radius of the sphere, so let's say that it's considered 25. Well, radius, then that would be considered 5. 3-dimensional. Again, if you look it up on the top, that's just like a circle. But you just look at this. So it's a sphere. Again, you can always show the transformation. So let's say that I want to put in, whoops, x minus 3 and then right here, so just insert that parentheses, y minus 3. Yeah, it's better to just reset it. It's hard to insert it. Okay, so let's just do it this way. So quantity, x minus 3. Raise up to the second power. Bring down the cursor. Plus quantity, y minus 3. As you can see that, if you just leave it like this, so that would be a surface of some kind of irregular or weird figure. And to the power of 2. Okay, so that just gives you the paraboloid. But now let's just put in something else. Plus z, the third variable, minus 2 quantity to the power of 2. So for the radius, again, I just want to use 5 as the radius. So 5 squared, then that'd be 25. It's a huge sphere. You just want to make it smaller. So let's say the radius is 3. So that means 9. So 3 squared is 9. So there's so many cool things that you can do. So right now, this one is just the basic stuff. You can put it in. But there's so many complicated equations that you can just, do that on the 3D one and also the 2D one. Alright, so thank you for watching the video today. I'll see you guys next time.